And today I'm going to talk about harnessing the power of Neo4j for overhauling legacy systems. And to go into my background a little bit, I've been using Neo4j in various scenarios for about 5 years now, and deploying to production for various use cases, using it in personal projects. And kind of lately, we did this project over at Behance with our activity feed, and it kind of opened my eyes to using Neo4j in kind of a different capacity, as opposed to for a new feature, for an experimentation, using it to overhaul something that we already had that existed, and kind of seeing the benefits that came along with that kind of project, in contrast to the ones that I usually work on. So just to go over quickly what I'm going to talk about, I'm going to quickly talk about what is Behance. Actually, Emil gave a great description this morning, so I could kind of cut most of that out, probably. And then I want to talk about why I look at legacy systems, so the actual premise of why I think that's a good idea and why it seemed to work really well in our use case. Then I'm going to kind of get into the more technical stuff, nitty-gritty, kind of the planning, get deep into our actual graph model and setup of our cluster to try to kind of talk about how we actually executed the project. And I also want to get into results, because that's a really important aspect of this actual premise of overhauling a legacy system, because you're able to kind of see those results relative to what you had before. And then I want to go over lessons learned, both good and bad. There's a bunch of those personal stuff that I messed up, that I could have done better, just that I was able to learn from this. Then quickly, what's next? And then the last point is kind of important. I want to take questions throughout, so if there's anything I'm talking about that you'd like more details on, or I kind of went over too quickly, feel free to just put your hand up and I'll take the question while I'm talking. I like doing that. So quickly, what is Behance? We're the leading online platform to showcase and discover creative work. We have more than 10 million members. And we allow creatives to share their work with millions of daily visitors. And in that process, they're able to kind of showcase the Adobe software they used to create that work. So if they use Photoshop or Lightroom to create that, we kind of advertise that, and it kind of brings more people to the Creative Cloud. And we're also becoming a platform for discovery, learning, teaching people how to use Adobe products. We have like live streaming videos now of people working with our products. So we're kind of like the community for the Creative Cloud. So to go over the actual, the main premise here, why did I see it as beneficial, kind of afterward, converting a legacy project to Graph and Neo4j. And one of the main points is you already know the pain points. So you might already have the system and you're well aware of what's bad with it. So you kind of know exactly what you're looking to improve, and you kind of have a good use case off the bat to make something better. And there's generally, kind of connecting with that, very low-hanging fruit. So you might have this legacy system that people already know, like, what's wrong with it. You might be complaining about it actively. That's kind of the scenario we were in. People were actively complaining about this old system we had, so we knew all those points. You could clearly demonstrate with real numbers, comparing to the old system, how a graph solution might be better. That was really important for us. And at the end, it makes it really easy to highlight the accomplishments. And that was one of the most important aspects of this project for us. We were able to look back and say, these are the concrete things that we were able to accomplish switching to a graph solution, because we had numbers and KPIs and all these things going off a legacy system. And if you're just kind of spinning up a new piece of architecture, you don't really have much to compare it to, how successful it was, or any actual metrics, usually. So just a quick history of our actual activity feed. In 2011, we used Mongo for the introducing the feature. I wasn't at the company at the time, but this is kind of the quick history. It was 125 nodes and a data set of about 20 terabytes. Then in 2015, we switched to Cassandra, and that was 48 nodes and a data set size of about 50 terabytes. And then in 2018, Neo4j, we're down to 3 nodes and a data set size of about 30 to 50 gigabytes. And I'm going to I'll go over how we got there and the techniques we use, which I think could be widely applied to different scenarios. So it's not really all specific to our use case. So just to kind of highlight the problems that we saw in these various implementations, Mongo, because of our kind of convoluted data model, we had very slow reads. It worked, but it was really, really slow. But kind of like Emil said this morning, we were able to see that people really liked it, and they really liked the features. So it was something we wanted to keep and continue to develop. When we switched to Cassandra, we fixed the slow read problems by introducing something called Fanouts, which is a strategy that you'll commonly see used in feeds and other things. I'm going to get more into detail about that in a little while. And the Fanout strategy became more problematic as our app grew. So as we added more users, more data, this strategy proved to be really, really convoluted, and I'll also get into that. It also, based on that, put large overhead on our web infrastructure. So you think about what powers your database, and it's usually not just a database. You have to write the data, and you have to have things that send the data to your database. And our web infrastructure was really feeling the heat of having to send all the data to Cassandra. And the big thing at the end is it required babysitting from our ops team, and that was a really big human resource strain. We're a pretty small team at Behance, even though Adobe as a company is large, and we were feeling the strain on ops, who was having to babysit our Cassandra cluster because of how much data we kind of threw in there after its conception and how much it was growing. And then Neo4j, we fixed the writing problem. We maintained the fast reads, and we also got a bunch of other benefits that I'm gonna get into. So this is kind of, like I said before, like I would describe the actual fan-out model that you usually see with Cassandra and feeds. So basically, you have a user here. We could say like a Behance power user, and we could say they publish a new project. So that's a common kind of data point in our system. Someone publishes a new project. And then you have each of the people here who follow that person. So in a fan-out model, you're going to write this piece of data to each of these people's feeds. So if if this person had 4 followers, you're going to write it 4 times to each of their feeds. But a common scenario in Behance is we have these really popular artists. So you might have a user who's followed by 10,000 people. So you could quickly see how this becomes really, really cumbersome and really kind of worrisome if you're growing and users' popularity is growing. You could be writing 100,000 pieces of data for one action that a user might take. So this was a really huge data set, and it was really growing quickly. So now I kind of want to get into actually how we came about Neo4j and bringing it into Adobe. No Adobe team was currently using Neo4j when I wanted to introduce it, and that was kind of a hurdle, bringing a new piece of software into a very large company. And I think so this might apply to some people here. If you're trying to bring it into any size company, it could always be something that you're going to have to sell in some capacity. So one of the useful things here is a graph model, and Neo4j itself makes it really easy to develop a proof of concept. You could do rapid prototyping. You could load up a ton of data right on your computer, which is what we did, and built a prototype to be able to show off what it could do. And kind of going back to the theme of legacy, we were able to say, hey, here's what we have now, and this looks really similar, and we're doing this with much less resources and a much nicer system. And then kind of management likes that too, because there's an easy kind of go-to-market strategy once you have the prototype. It doesn't feel like as much work is remaining. So just to quickly go over what some of our goals and KPIs were with this actual project, kind of relative to what we had. We wanted a flexible, efficient, and robust system. And a big thing with that is we wanted to be able to easily build on top of it. We couldn't do that with Cassandra because our schema was rigid. We couldn't query the data how we wanted to. So that was a requirement that we wanted going forward. We wanted to be able to add new stuff. We wanted minimal maintenance and upkeep. Like I said before, our ops team was getting drained, so a requirement is that we wanted minimal maintenance just for patching and not have to have it babysitted. Minimal data storage requirement. We wanted to try to keep it under 100 gigabytes. Smaller cluster size. We were shooting for a cluster size of 3. We weren't sure if that was possible, but we wanted to keep it easy to maintain and easy to understand. Reduced overall complexity, not having all the all the issues on the website, being able to keep it really simple, maintain fast feed loading. We wanted to not lose features. We didn't want to switch to Neo4j and get optimizations and lose user-facing features. So that was one thing we were judging this about. We wanted to maintain the same feature set or better, and then a lower cost of running the feature. You could probably imagine 48 pretty big Cassandra nodes on AWS was not cheap. So we wanted to cut that cost. Sorry, I'm just going to grab a drink. So this is kind of getting into the really technical part of how this actually works relative to our Cassandra Fanout strategy. And it's kind of a concept that I call tiered relationships. And this is actually a concept that I think could be useful in a lot of cases where you're kind of trying to replace something that has a lot of relationships, has a lot of potential for supernodes, kind of like we did. So what a tiered relation, just to go into like how Neo4j stores relationships, which most people might already know, they're stored by type and direction. So if you're accessing a lot of relationships that are the same type and direction coming like, into a node or out from a node, that's going to lead to slower path traversal. And that's kind of like the supernode problem. And for those who go back really, really far using Neo4j, you'll remember when it wasn't even stored by type and direction. It was stored just any relationship leaving a node or whatever, and this was a huge optimization. So kind of thinking, how can we take advantage of this for a system like this? So tiered relationships, what the idea is, you offer your queries different levels of access by creating relationships that store a certain amount of the latest events. They don't store all the data. They give you kind of a granular view of that actual data. And I'll demonstrate this in a diagram in a second. So your data, you're storing more data than it was perfectly normalized, but you're getting a huge optimization, and you're still not writing nearly as much data as the fan-out strategy, which we'll see. And it's very useful for feeds, follower-based systems, any system where you might run into a supernode problem. So this is a very obvious basic relationship. On Behance, we have an action called appreciated. That's like when you like someone's project, pretty much. So this would be a really basic storage of that relationship, a user appreciated a project. And we do use this model. But in addition to that, we use tiered relationships. And this is what I consider tiered. We have a relationship like has recent action 200. So what that means is we're storing in that relationship the user's last 200 actions. And we're storing a type of what that action was. So if we want to load a feed for a user that's following just a few people, we could access has recent 400 and query more of all those people's last actions. But if we're loading a feed of someone who follows a ton of people, to optimize it, we can only analyze the last 200 actions of each of the people they follow. So it creates these different views that you could kind of query really nicely in Cypher and kind of get that granular view in a really efficient way. So you can see we just have that and that. Just to get a little more into the actual infrastructure we used, we have a 3-node cluster, 8 cores each, 2 terabyte SSD, so we have lots of room to grow there on our actual data set. We're nowhere near that, which is nice. 118 gigabytes of RAM allocated to each of the instances, 50 gigabyte page cache, and 15 gigabyte heap. And a really interesting thing is our system's been so performant, we haven't even tweaked these at all. This is kind of what we went with from the beginning, and we haven't had any issues on that system with the 3 nodes. Just to get a little bit into our actual cluster, and I'm going to kind of talk about this a little bit towards the end, but we use causal clustering, and this was the first time I had used causal clustering, and we'll go into how we kind of got there, because I came from a background of using Neo4j HA all the time, so I was a little hesitant. But this has worked out really well for us. It works really nicely. We have a 3-core cluster. We write everything to the leader, obviously. We divide all the reads between the 2 followers, and we could lose a single node in our cluster, and everything's still good. So this has been really stable. We haven't had any issues with clustering, and it's been pretty nice. So just it's been stable for us. We have a really robust backup solution built around causal clustering, and that was built by my colleague Gabe, who's here, and he kind of became an expert on backups and causal clustering, and we have a whole automated process. And we built it into a DCOS app that we use, which I'll show in a second. And the backups, you're able to restore one of our backups to a new Neo4j cluster with just a few clicks. So it's a really nice peace of mind to have, and it's one of our kind of cool things. That's just a quick show. So this is built on top of the open source Neo4j DCOS app. If you look on one of the repos, you could kind of get a base for it. We did a lot of customization with like our backup stuff. So this is just a basic shot. So this is actually a technique I just want to talk about we use during our deployment process called dark launching, which I've found useful in almost all the Neo4j projects that I've worked on. And basically what you're doing is you're launching kind of your production scale app behind the scenes and asynchronously. So you're able to test everything, you're able to measure KPIs, you're able to measure performance, but you're never affecting the user-facing site. And we've kind of found this better because you're able to mimic production traffic. So what you'll do is kind of have asynchronous jobs go off in the background whenever anything happens to mimic that exact traffic pattern. Because we have a lot of times of spike activity and everything that we want to measure and make sure everything works well. And why do you do this? Because you can measure KPIs, measure performance, and it also gives you a built-in like ramp-up strategy. So what you could do is when you're ready to go to prod, you kind of take it at a dark and you put it to light, and you're scaling down the other system. So for where you're replacing an architecture like we were with Cassandra, this is a really useful strategy. So you're kind of you could see the numbers kind of going on to the other system, which is kind of nice. So just basically going to prod, we followed a documented rollout plan that my colleague Mike developed for us, percentage-based rollout. We dealt with our community team to make sure there were no issues. We made it to 100% after a couple days, and we decommissioned our Cassandra cluster a few weeks later. So just to talk about some of the wins that we've kind of had with this project that are kind of interesting and kind of drive home that point of being able to measure KPIs and wins, how it's useful for kind of bringing in a new technology like this, because you're able to show stuff like this. So our human maintenance hours are down well over 300% with Neo4j. Our ops team is loving it. This was a huge win for us. They were having to babysit the old cluster, and they've just barely touched this one, which has been really a huge win for the project. Kind of like I said before, 1/1000th storage. We're at like 50 gigabytes or whatever versus 50 terabytes with Cassandra, and that comes down to the Fanout model. When you get rid of the Fanout model, we were able to scale down that data exponentially. Powered by 3 instances instead of 48, which is really nice, lower cost. And we get better user-facing functionality for free. And that was an important thing, and I think that's one of the huge advantages of Graph. And you'll see that in a second. I'll show some images kind of what that looks like. And we get easy extensibility thanks to the Graph model. I'm also going to show that in more detail. And we already added a new feature, which is kind of exciting. And replacing the legacy system, like I said before, concise and demonstrable metrics, and we'll be able to show those. So this is the experience that kind of kicks off the activity feed in our actual app, and it's pivotal to the actual experience on Behance. So basically, when a new user signs up, they're going to see this screen, and they're able to select these things called curated categories, where these are actually curated by our professional curation team, and we load them up with projects that fit into those criteria, and they're kind of handpicked. So what you'll do is when you come into the experience, you'll select which one of those you want to follow on your activity feed. So what'll happen is you'll select those. So here we selected 2, and you'll click to go to the next screen, and what you're going to see now is a loading screen. And this says creating your custom feed or whatever. So this screen is actually really important because this is one of the wins here that we kind of highly optimize this. So you'll see the screen for a certain amount of time, and then you'll see your activity feed. And this is basically the activity feed experience. Here I'm following a bunch of curated categories, so I see content from those, and it's an infinite scroll system, so I could keep scrolling. And that's also important to one of the wins. So what this is actually a chart of, go back for a second, of how long this screen is visible on Cassandra versus Neo4j. So this is one of the really cool things that you're able to see because we have these numbers. So on Cassandra, if you selected any more than 3 categories to begin, your initial load time into Behance was more than 1 second. If you selected all 13, which we have a lot of users do, you would be a 4-second load time on that spinning wheel screen before you're able to actually use our product. So in Neo4j, because we were able to take advantage, again, of Fanouts removed, we have all categories selected well under 1 second. So this was a huge win for us. This is the actual opening experience to our app, and it's just much more quick now. And that's not the only win we got there. This is actually just another graph of the same thing. This is where we cut over, so this is the actual average onboarding time, and then this is when we cut over. Kind of really, you can see lots of spikes here, and you can see really consistent here once we cut over to Neo4j. So what this is, just to go back again, I'll show. So we get 1,000 projects now per followed category with Neo4j, as opposed to 30 that we have with Cassandra. So if I go back for 1 second, that means with Cassandra, if I selected, for instance, 1 category, which we let you do, I would only be able to scroll through 30 projects. If I selected 260. Now, if I select 2 curated categories, I get 2,000 projects I could scroll through. So instead of people really not having a good experience when they start using the app and quickly running out of content, we have lots of content we're able to show them now because of the dynamic functionality of the graph. That's all by not having fanouts, and it's just a better overall first impression of our app. So another thing, kind of like I spoke about before, we greatly reduced the web overhead of our app by not having to write tons of stuff into Cassandra. Show this. So this is the actual, Emil touched on, kind of stole my thunder on this one this morning. He said, we used to have actions. This one's was a more optimized one, but we had some actions that would take like 15 minutes to broadcast, and they would use a ton of our web worker resources while they did that. So you can see this is kind of before we cut over, and once we cut over, the actual resources on web and the time it takes to write an action is really, really fast. So just imagine we used to have these actions that took a half an hour for some of them, because they would literally write like 100,000, 200,000, some of them feed actions per each action, and we had lots of those per day. So this is the same thing, comment, you can see really just different spiky times and then very consistent here. So this is one of my favorite wins that we've gotten from the project because it really shows the flexibility of Neo4j and graph databases as a whole. This feature right here is live on our site right now, and users are really liking it. It's basically new projects created by people you follow. It's kind of a sub-view of the activity feed, and this was not previously possible with our Cassandra-based architecture with the schema we had. So we were able to really easily add this, and it's something we always wanted to do but couldn't do. And the really impressive thing is this was actually created by my colleague Yuri, who's also here. And he had never used Neo4j before, and he was able to do it in a couple of days on our, and have it going in production. And that was really impressive to me, and showed, the flexibility of the system relative to what we had. Then we get some basic wins just because of the more normalized model with feed continuity. Cassandra, for the model we had, we couldn't really delete data how we wanted to. It was really hard to. So with Neo4j, we get basic continuity, like when you unfollow a user, for instance, that content disappears from your feed. And that might seem like a small win, but this is kind of what I was talking about with the low-hanging fruit before. This was an optimization we got for free that people were impressed with off the bat. They said, hey, now my feed actually reflects the people I follow if I unfollow someone. And like I said before, feed broadcast times are way down. So just to quickly summarize the lessons we learned on this project that I hope could be more applicable outside our specific use case. Comparison metrics between two systems with the same goal are compelling. I hope those are pretty compelling. When we show them off internally, people really like them because they kind of, they were used to seeing that loading screen on Behance and how long it took. They were used to running out of content when they signed up, so those are pretty cool. One thing I kind of learned with this project, I was kind of sort of new to Adobe. I've been there for 3 years now. But when I wanted to kick off this project, I was kind of new to the company, and bringing in new technologies to large companies could be a hard process. One thing, if you are in a large company, you might already be aware of this. I kind of learned, which I didn't know, is it's good to have someone who's familiar with the procurement process. We luckily had someone who was, and he was really good at kind of getting it through and getting us an enterprise contract. And I think that this is a kind of good one for general use of the strategy. Areas that have been neglected for a long time and you might be complacent are primed for projects like this. So you might have that aspect of your stack where everyone's like, oh, like we kind of just deal with this thing or whatever, and it kind of sucks. Those are kind of technologies that are usually primed for stuff like this. If your company is hesitant, on bringing in a new tool like Graph Database, don't give up and kind of keep the pressure. Like especially in a big company, you might need to do a lot of convincing. That's kind of why I went over the selling points before. So that could be important. If your company does put you in a position to bring in new tools, hopefully you're able to take advantage of it. Kind of today, if you look at some of the graph use cases, hopefully you get some ideas of how it could be applicable to what you're doing, and take advantage of using the new technology. And this kind of bubbles in to the last one I have here, which was kind of, although I wanted to use Neo4j, I wanted to bring it in for this project, I was hesitant to use causal clustering, and I had to be convinced by my colleague Gabe. He was like, let's try the newest thing or whatever, and I was hesitant to try something new, and it worked out really well. We kind of put together a methodology to test, so that worked out well. Just one more slide here. What's next for us? In the near future, we're trying to encourage our dev teams to think more about benefits of Graph, and now that we have this infrastructure, how we could use it. A good example, again, was the new project feature that we were able to implement really short after. We might introduce more granular ways to view activity by appreciated comment instead of just projects published. And in the future, we have a really cool kind of setup to do different things based on our activity feed, like similar users, to people you're following, kind of collaborative filtering based on activity data, and then being able to kind of store cool actions is also an idea we've discussed. So we also have views, but then maybe like how long you viewed a project or something. So having really cool kind of metadata in our graph that allows us to query it in interesting ways. So that's something I definitely want to think about, the possibility of using a recommendation for recommendations. That's all I have. I don't know if there's any questions, but I'm happy to answer anything. Yes.
Well, yeah.
Thank you. That's a great question. Before, for most features, we'd have a meeting about it and then decide it would just take too long, and we'd end up not doing it. That's pretty much how it went down. And that was for like a year, like while I was here. And that's one of the things that I wanted to be able to do and be able to add new features like that. Yep, that's all I got. Thanks everyone.